Hey, what's up everyone? So today it's a new video with a guest and I'm pretty excited about this one because today I have with me someone who actually made a contribution to the Swift language. So welcome Cal, thank you for being with me today.
Hey, good to see everyone this morning. My name's Cal Stevens. I work in the tech industry. I live in San Francisco and uh, reasonably active in the open source community. As Vincent mentioned, have done a few contributions to Swift itself over the past year or so. Also active in other projects. I contribute a lot to the Swift format open source code formatting tool. I'm the lead maintainer of the Lottie project these days, and of course, really interested in Swift and participating in Swift evolution.
I didn't know you were the maintainer of Lottie, but I've just used it today. So nice to meet you as the maintainer of Lottie. And so the reason why I asked Cal if he would do a video with me is because you have implemented the new shorthand syntax for the if-let statement in Swift. So since Swift 5.7 that came out a few weeks ago, we no longer need to do if-let variable equal variable, just if-let variable. And I wanted to ask you about how it went to implement this change. So I've prepared a list of questions, and my first question was it your first contribution to the Swift language?
Great question. I've participated in the Swift evolution community for many years. I honestly think I browse it every week at least for many years, and I've floated lots of different ideas over the years and submitted a few proposals that did not end up getting traction and going to the review phase. But this proposal was the first one that I ran that actually made it to a review, and of course, it was my first one that actually got accepted and included in Swift.
And yeah, I think it's interesting what you're saying, the fact that you were following and contributing to the Swift forums for a long time, because I can tell you that for myself, I'm following from afar the evolution proposals. But if I were to formulate one, I would be like, whoa, I'm like, I mean something like way over my head. And I think, yeah, you really need to be like part of the system, the ecosystem, understanding how things are going. Just because it's, I think we're going to talk about it a bit later, but it's a big work to write, defend, and implement a language that will affect the entire language. Like,
Yeah, absolutely. Yeah. That the specific word you said, defend, is so interesting because obviously anyone can post on the evolution forums, but then like advocating for your idea and defending why it's a good idea and why it is not only a good idea but worth modifying the language to include permanently, it is a high bar, and not for the faint of heart. Obviously, most of the things I've posted have not met that bar. But getting constructive feedback from the community, and especially from the core team and the language work group when they do lend their opinion, is really helpful, and for informing like the way that you want to shape your idea and your contributions.
and so to keep talking about this idea that you had that made it into the language, how did you get this idea that yeah, adding a shorthand syntax for the if-let statement would be a valuable addition to the language?
Unfortunately, I can't take even a single piece of credit for the idea at all. This specific feature, the notion that we needed a shorthand way to unwrap optionals and work with them immediately, has been requested for many years since Swift 1.0. Really, it's been like on the community wish list. Most recently, and what put it on my radar was in around May 2021. Um, One member of the community who's pretty big on Twitter as well, Craig Hockenberry, he posted on the evolution forums, just with his argument for why we needed a feature like this, and his proposed spelling design, which is the specific design that he proposed is different than what we ended up going with. But of course, that entire his pitch thread from last May included all sorts of different design suggestions, including the iflet that we ended up going with. So in 2021, I was interested in actually making a contribution. So I was looking for ideas that seemed feasible for me to implement as a novice to the C++ compiler code base. And that I saw that one and thought that it was approachable. And I personally liked the specific iflet syntax that was proposed by one of the people in the thread. So then I wrote my own pitch thread, linked to Craig's pitch thread, and then had very extensive discussion about it. Of course, with the implementation this time, which qualified it for a proposal review.
I think it's super interesting what you're saying because I guess we can all have the false idea that you need to have like the brilliant idea that comes out of nowhere, like while coding. Oh yes, we should do this, and it's going to be so amazing. But actually, it's not necessarily the case, and there are already a lot of ideas like floating around. And sometimes it's more a question of like, yes, I will focus my attention and energy on that idea and turn this idea into something that actually happens and is part of the language.
Yeah, especially just that it's such a community process, because lots of people have ideas that they suggest and that are good ideas, but a requirement for going to a official proposal review is to have an implementation that is usable and actually works in the compiler code base. And that's a high bar that even like someone who has a really well thought out proposal for a new language feature may not be interested, able, or willing to actually do the implementation work. So that's a cool place for the community to come together and shape things together.
And so you are mentioning the fact that to pitch an idea, you need to have an implementation. And could you like tell us what does this entire process looks like? Like if you want to contribute to Swift and contribute a new feature to Swift, what does the process look like from start to finish?
Let me pull something up. Of course, this is the first thing you need to know if you're interested in making an evolution contribution. And in the Swift evolution repo on GitHub, there is a document that outlines the entire process for evolving Swift. Your question was how to propose a change. So to run through the proposal process, it all starts on the Swift evolution forums. Anyone can post there in the Swift evolution pitches category and make a suggestion for a new feature and get feedback on it. People typically ask questions about how it interacts with other language features or clarifying questions about how it works in general. And people often share useful feedback. After the pitch stage, once you address community feedback, you can take your proposal to the proposal stage where you actually write the formal markdown document that you would then submit to the evolution GitHub repo. And of course, anyone can write a proposal and submit it. But one requirement for actually submitting a proposal and having it be considered to be reviewed is to also have an implementation of your proposed change. So that requires making the code change to the Swift compiler code base and testing it, writing tests, showing that it actually works. And once you have all of those things, you can submit your pull request with your proposal, links to the implementation, to the Swift evolution GitHub repo, and the language work group. At that point, will evaluate your proposal, see if they think it has a chance of success. I don't exactly know the criteria that the language work group uses for taking a proposal that's been submitted to actually review. I have a feeling they do a preliminary gut check on if they think it is plausible to be accepted. But then at that point, if the language work group can choose to schedule it for an official review, that's 2 weeks. It gets posted an announcement, and they solicit feedback from the entire community. Then at that point, after the review period, the language work group will review all the feedback and consider it, and then make the final decision as to whether or not the feature is a good fit and should be included in Swift.
And so, if I get it right, so you said you need to have the implementation ready for the proposal to be accepted. So you need to have some knowledge of the compiler. or find like a co-author that can work with you and that has knowledge of the compiler. And I guess it's also very possible that you spend a lot of time implementing something in the compiler, and if the proposal isn't accepted, that work will basically go to waste, right?
Yes, you are absolutely correct about all of those points. I do know that finding someone to work on the implementation is often a barrier for community-driven evolution pitches, and a lot don't make it to the submission stage simply because there's no one with knowledge to and interest to do that implementation work. And of course, like you mentioned, it's risky to invest a lot of time into learning how to contribute and then making a change to have it then not be reviewed or be rejected. So that's why the pitch phase is so important, to really get a pulse on what the community thinks. And if you're really lucky, hear some personal opinion from members of the language work group. In the case of the if-let proposal, in the pitch stage, there was sufficient, in my opinion at the time, there was sufficient support from the language work group that it seemed plausible that they would at least run it, which was the aspirational goal for me at the time, was to actually even get a proposal ran to the review stage, which I had never gotten before. So that seemed likely at the time. So that I took the time to implement the change.
And one of the things that we discussed before we recorded the video was the fact that compiler implementation are not necessarily like super big, scary things. Like, I think you can show us what the implementation of the feature look like in the compiler, and you were telling me that it's something around like 20 lines of code.
Yeah, this change in particular was really not that involved because the feature is really simple. But to kind of intro to what it's like to work with the Swift code base, of course, there's a repo on GitHub, github.com/apple/Swift. You can clone it, download it, and build it and run it locally. The first obstacle is, of course, getting the thing to build and run on your machine, which there are guides for how to do this in the repo. It's a huge project. I think since it depends on LLVM and all of that compiler infrastructure, I'm pretty sure the source code checkouts alone are in the order of 10 gigabytes or more. And then once you actually build all of LLVM, all of Swift, on my machine, the way I've been building it, I get like 100 gigabytes of build products. So getting the thing to build in itself is the first step. But once you have that, what I think makes it actually surprisingly approachable to work on the compiler is that you can generate an Xcode project. The code itself is in C++, which is not familiar to me as a Swift developer. But the fact that you have an Xcode project that you can build and run like any other app that you would work on, and that you can set breakpoints, and that you can use LLDB and print and the things that you see in the functions. The experience of actually debugging the compiler is way better than I expected, and in my opinion makes it really surprisingly approachable if you're willing to put in the time to.
Yeah, I see what you mean, because since the tools are similar to what we use to make iOS apps, even though the language and the paradigm are different, we still get that sense of familiarity, and you're not completely into the unknown.
Yeah, absolutely. I don't think it would have been possible for me to make any changes at all if, for example, I didn't have LLDB in Xcode that I was already familiar with. Like if I had to attach to the compiler process in the command line and use LLDB in the command line and set breakpoints in the command line, I don't know how to do that. If I had to learn that first, like learn an entirely new debugger tool chain and UX to contribute, it would have been much more challenging. So that was really helpful.
And so since the Swift compiler is public, I guess your pull request is public also. And so I guess you can show us actually what was that code that you wrote to add the feature to the language.
Of course. The the thing that always just makes me laugh about this proposal in particular is that the proposal document is easily thousands of words. And the review thread has like 250 replies. It's in the top 10 evolution review threads of all time when you sort by reply count. So very controversial, extensively discussed, lots of topics you have to cover on the proposal side. But on the implementation side, the code change is like 20 lines of additional C++ code in the compiler plus tests. The approach that I went with for making this change, which I actually have no idea if this is the best change, the way to approach this change or not. It was the easiest for me. The code reviewer did not complain, so it must be reasonable enough. But what I did was in the parser, where the compiler parses your source code file and creates the individual syntax tokens that it then uses later in the compilation process. When the compiler is parsing if let variable into that optional unbinding pattern, if it doesn't see the equals token, all it does is that it pretends that it saw the equals value. So instead of seeing if let value, it pretends that it saw if let value equals value. It creates the same tokens, the same syntax tree elements as if you had typed that in the file, and then just carries on. The whole rest of the type checker and actual code generation, all unchanged, doesn't know that this feature exists. It just implicitly creates the syntax as if you had written the old syntax. So that made the actual code change very lightweight. I'll kind of narrate what this C++ code is doing. The names in particular of like these elements took me a really long time to get used to because they're pretty brief and opaque. And I think that's probably because the compiler has the compiler codebase has a 80 column line limit that they lent an auto format for. So 80 is pretty small in my opinion. And when you have an 80 column file limit, you really have to make sure your names are pretty brief. But to look at this particular, you can see before that this is the parsing for a conditional element inside a conditional statement. So like an if statement, a while statement, or a guard statement. And it's already parsed the left-hand side, so it has let value. And then it's checking, previously it would check if it sees an equals token, and if so, then it would parse the right-hand side as an expression. So that could be any sort of Swift code at all that creates a value. Now, in the new code, if we didn't see an equals sign and the left-hand side has a name, so value, then all it does is that it creates the right-hand side as if the user had written value. And in Swift, an expression that refers to a value that's been defined elsewhere is called a decl ref expression, so a declaration reference expression. And in this case, we don't know what the type of that declaration is since we're in the parser and not the type checker. So we create an unresolved declaration reference expression for the name of the left-hand side of the expression. And of course, like I mentioned, we marked that it's implicit. The user didn't write it, we created it. And that's it. From there, the type checker, the code generation is all the same.
And it's super cool to see that when you look at the feature from the language point of view, it feels like it's just something that removes a duplicate. And when you look at the code, it also feels like indeed it's just removing a duplicate, and there isn't that much complexity in it.
Yeah, exactly. It's really quite a simple change. The change to the formal language grammar is really small. It just makes the piece optional. The change to the user-facing language model is really small. And of course, the change to the implementation is pretty small as well. Now, one other thing I want to show you, just because it's interesting, you may find it interesting, is the way that you write tests for the Swift compiler. And I thought this was really cool when I was working on this. So the compiler has a whole bunch of test suites. Obviously, you need to verify that the expected features of the language do compile successfully. You also need to verify that things that aren't supposed to work don't compile and that they fail with specific errors. So when you're writing tests, you create a Swift file that's just normal Swift code, and you annotate it with the expected errors, warnings, and messages that the compiler emits. And then to run the test, it compiles the file, validates that all of the errors and warnings are expected. Yeah. So, for example, this is one of the new test case that the pull request added. It of course validates that you can use the syntax both with let and with var, and it also validates related features, like for example, that when you use if let with the new syntax, that the compiler doesn't let you modify that value, because of course that's how the feature is expected to work. So you want to have tests for all of that. But for example, since we used var opt in this case, you can mutate it. So writing test cases for the behavior of the compiler is actually surprisingly really easy.
Yeah, I agree with you. It's like it's a very smart syntax, and I'm sure like now that I've seen it, maybe like one day I will have like the inspiration to use that same approach for a different problem, but to say like, okay, this is what I want my system to process, and I'm saying, okay, here it should generate that error. That's a pretty cool way to write tests, and like you said, like it's pretty like low overhead. And so to come back on the topic of contributing to Swift in general, I found really interesting the imbalance that you showed between how little code there is when compared to like how much work was done to convince and advocate for the ideas. It shows that this requires technical skills, but not only technical skills, also like skills to just defend your idea. Like you said, the word defend might be the important word. And so now that we've covered what the process of contributing a new feature to Swift looks like, I wanted to ask you, now that for you this is over, that's it, the feature has been released. If you look back at it in hindsight, what do you feel was the most difficult or challenging part of that process?
The hardest part, without a doubt, was choosing the specific syntax, spelling, design for this feature. Even in Craig's original pitch thread from May 2021, if you read that thread, there was really solid consensus among the community and among influential members on the core team and language work group that this was a problem that was worth solving somehow. Of course, at the time, there were almost a dozen different proposed ways to design this feature. Examples that come to my mind include if value question mark, if let value question mark, if unwrap value, unwrap value, an unending platter of different options that we could have picked. So choosing the one that fits most nicely with Swift today, but also dovetails nicely with proposed future features like advanced borrow introducers, ref and in-out, all without increasing the overhead of the language conceptually by adding new keywords, for example. All of those things were really important to consider. And in the proposal document, it of course lays out why the final if let spelling is the best of all those options, in my opinion, and obviously, of course, in the opinion of the language work group.
But you know that now that you mention it, I remember reading your proposal so in a live a few months ago, and I remember that when I had reached the part about the alternative syntax, and when we started to talk about this thing that you said, the borrow keyword that might be a thing in the future, I was like, okay, there is really like more than meets the eye when you want to make a proposal, and it seemed like if it is challenging to read, it must have been even more challenging to write it and to come to that conclusion.
Yeah, it took a long time, different iterations, lots of feedback from various folks. Ben Cohen, who was on the Swift core team in particular, was very helpful on the transition from pitch to proposal with suggestions of topics that he thought that I should address in the proposal. and supporting arguments, for example. Considering how this feature would interact with borrow introducers that we may get in the future was next level, because these features, they don't exist. No one has used them, and we don't even know what they'll look like. But it matters, because features that we introduce today to Swift are permanent. They will exist forever. And if they make it more challenging to design new features in the future, then that's a problem that we're going to have to live with. So it was really important, and I think we did it justice and made the right call.
And I think I have one last question for you. And that question is consider like someone like me, for instance, who follows the language, but who never really took the time to read the Swift forums in depth. What advice would you give me if I was to tell you, like, yeah, I would like to contribute to the language? Where should I start?
I think just the best place to start is just regularly reading and browsing the Swift forums. For example, I think it's really interesting, which is why I do it. But seeing the types of features that folks propose and the feedback that the community gives them really helps inform your idea of like what types of features the community is looking for, and helps you maybe anticipate the reaction of the community before you propose something. But also, if you have an idea, I would suggest sharing it. You could even tweet it and see what people think as a first way to socialize your idea. But if it seems useful to you, you could pitch it and get input on it. And if it is a really, really useful idea, someone interested in implementing it might be willing to work with you on that, or you could take the next step and dive into trying to do it yourself. But just participating in the community, sharing your ideas, sharing your feedback, and sharing constructive feedback on other people's proposals is a really great way to get started with the community, and is open to anyone.
Yeah, I think it's a great advice, and I think it's also like nicely fit with everything you've been saying throughout this video. That it's more of a convincing, defending, argumenting process than a technical process. Even though there is a technical part to it, but it's much more important to convince people than to write the implementation of your feature.
Yeah, I think that's often the case.
All right, so thanks a lot, Carl, for this discussion and for all the answers that you gave to my questions.
Absolutely. Thanks for having me. I really enjoyed it this morning for me, and this evening for you. I really enjoy participating in this community and talking about this work. So thanks again for having me.
And I hope that you've also enjoyed watching this video. I know that I've definitely enjoyed doing this interview. And I guess I just have to say thank you for watching, and see you next time. Bye-bye.
Bye, everyone. Catch you on Twitter.